Thermal properties of matter. So thermal in the sense of heat. What is heat? What is heat? Heat is a form of energy. Yes. Which
Yes.
produces in us the sensation of hotness or coldness. So this is called as a heat. Now, caloric theory of heat. What caloric theory of heat will say us? According to caloric theory, heat is an invisible, weightless, and odorless fluid. It's called caloric. Heat is an invisible, weightless, and odorless fluid called caloric. Next one is dynamic theory of heat. What is dynamic theory? According to the theory, all substances, which means either it may be a solid or liquid or gas, all substances are made up of molecules. These molecules are in a state of random motion. So random motion in the sense of that may be translatory motion, vibratory motion, or rotatory motion. Rotatory motion. So what is translatory motion? The motion of a molecules in a straight line. Generally, which is common in gases. Which is common in gases. Because gas molecules are loosely packed, it may travel in a straight line. Vibration motion. To and fro. To and fro motion of the molecules about their mean position. About their main position. This is common example of liquids and gases. The vibratory motion is possible. Next, rotatory motion. That is the rotation of the molecules about their axis. This is called as rotatory motion, which is usually happening in high temperatures. Rotatory motion is possible in high temperatures. Once we can discuss about caloric theory of heat. Heat is an invisible, weightless, and odorless fluid called caloric. When some caloric added to your body, its temperature will be increased. Okay. And when some calories are removed, what happens? Temperature will be falls down. However, this theory failed to explain the production of heat by the friction. Friction also will give the heat. But caloric theory was failed to explain. Units of heat. What are the units of heat? CGS units are calories. How to define 1 calorie? 1 calorie is defined the heat energy required to raise in temperature of 1 gram of water through 1 degree centigrade. No. As a unit of joule, as a unit of heat is joule. So 1 calorie is equal to 4.186 joules, approximately 4.2 joules. Yes.
Yes.
Next, mechanical equivalent of heat. Joule mechanical equivalent of heat. How it is? Joule established the relation between work done and heat produced. He showed that whenever an amount of work done W you are giving to your object will increase the heat, which means how much work done if you do, that much heat energy will be produced. W is directly proportional to Q. So W is equal to J into Q. Implies J is equal to W by Q. So the proportionality units constant J, we can call it as Joules mechanical equivalent of heat. So 1 joule is equal to 4.186 joule per calorie. That is equal to 4.186 into 10 power of 7 erg per calorie. Okay. Got the point?
Yes, sir.
Next. Thermometric scales. Thermometric scales. The range between two temperatures is called as a fundamental interval. Generally, thermometric scales are Celsius scale, second one, the Fahrenheit scale, Reaumur scale, Kelvin scale. What is the Celsius scale? Celsius scale, lower fixed point 0 degree centigrade, upper fixed point 100 degree centigrade. Between that, there are 100 numbers will be there. Okay, so each will be 1 degree centigrade. Coming to Fahrenheit scale, lower fixed point 32 degree Fahrenheit, upper fixed point 212 degree Fahrenheit, and the time interval between that 180. So that is 1 degree Fahrenheit. Reaumur scale, lower fixed point 0 degree Reaumur's, upper fixed point 80 Reaumur's, time interval 80 Reaumur's, which is equal to 1 hour. Kelvin scale. Kelvin scale, lower fixed point 273.15 Kelvin. Upper fixed point 373.15 Kelvin. Totally 100 equal parts. Okay. So each will be 1 Kelvin. This is. Now, conversion of temperatures from one scale to another scale. How it is. Generally, the conversion temperature on one scale minus lower fixed point by upper fixed point minus lower fixed point is equal to temperature on other scale minus lower fixed point by upper fixed point minus lower fixed point. Clear? As per that, degree centigrade minus 0 by 100 minus 0 is equal to TF minus 32 by 212 minus 32 is equal to TR minus 0 by 80 minus 0 is equal to TK minus 273.15 by 373.15 minus 273.15. So TC minus 0 by 100 is equal to T2 minus 32 by 180 is equal to TR minus 0 by 80 is equal to TK minus 273.15 by 100. So this is the most important. Absolute scale of temperature, what it is. Absolute scale of temperature means absolute zero temperature. According to Charles' law, if Vt and V0 are the volumes at T degree centigrade and 0 degree centigrade respectively. So of a given mass at a constant pressure P. So Vt is equal to V0 into 1 plus T by 273.15. For clearly, the gas below 0 degree centigrade will be less than V0. So V minus T is equal to V0 into 1 minus T by 273.15. If you draw on the scale, this is temperature and this is volume. This is at 0 degree, 100, 200, 300 degree centigrade. If it is in Kelvin, 573 Kelvin, 473, 373, 273, and still less over here, minus 100 degree centigrade, minus 200, minus 270 you can take it over here, 273 you can take it. While Kelvin, 173, 73, 0. Now here, this graph will come. This is extrapolation. Here you can able to understand the decrease of the temperature results the decrease of the volume. Yep. Now the volume against the given mass against the temperature at a constant pressure. The graph is a straight line. If we extrapolate, the straight line meets the temperature axis at minus 273.15 degrees centigrade. Thus the gas occupies zero or no volume at minus 273.15, but which is meaningless. Every gas having its own volume. Moreover, according to kinetic theory of gases, all molecular motion stops at minus 273.15. A faulty thermometer has its fixed points marked as 5 degrees and 35 degrees. Temperatures of a body as measured by the faulty thermometer is 59 degrees. Find the correct temperature of a body on Celsius scale. How to answer this? Tc minus 0 by 100 minus 0 is equal to temperature on faulty scale minus lower fixed point by upper fixed point minus lower fixed point. So Tc minus 0 by 100 is equal to 59 minus 5 by 95 minus 5, which is equal to 54 by 90. That implies Tc is equal to 54 by 90 into 100. So 540 by 9, 60 degrees centigrade. At what temperature do the readings of Celsius and Fahrenheit scales coincide? Let's say Tc is equal to Tf is equal to X. Tc minus 0 by 100 is equal to Tf minus 32 by 180. So X by 100 is equal to X minus 32 by 180. 180X is equal to 100X minus 3200. So 180X minus 100X is equal to 80X is equal to minus 3200. X is equal to minus 3200 by 80 minus 40 degrees. Minus 40 degrees. Hence, minus 40 degrees centigrade and 40 degrees centigrade fair identical temperatures. Repeating. A constant volume gas thermometer using helium records a pressure of 20 kilopascal at a triple point of water and pressure of 20 kilopascal at the triple point of water and the pressure of 14.3 kilopascals at the temperature of dry ice. What is the temperature of dry ice? Now we need to understand what is triple point of water. Triple point of a water at which the three phases of water, namely ice, liquid, and water vapor. Water, vapor are equally stable and coexist in equilibrium. Okay, it is because of it occurs the specific temperature at 273.16 Kelvin and the pressure of 0.46 centimeter of Hg. So pressure at a triple point is equal to 0.46 centimeter of Hg and the temperature of a triple point 273.16 Kelvin or 0.01 degrees centigrade. Hope you understood that the triple point what it is. The three phases of water, it may be in solid state or liquid state or water vapor state, are equally stable and coexist. So at 273.16 Kelvin, all are in the same stable state. The pressure of the three 0.46 centimeters of Hg. Yes, how to calculate this answer? Temperature triple point 273.16 Kelvin. Pressure at a triple point of water 20 kilopascals, what they have given. Yeah. Now pressure P is equal to 14.3 kilopascals. Now temperature of dry ice T is equal to P by P triple point into T triple point. So 14.3 into 273.16 by 20 is equal to 195.3 Kelvin. Clear?